Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review what was covered in week 2. So this week we just looked at factors and multiples as well as prime numbers. So factors of a number are numbers that are less than that number that go into that number. So if I want to find factors of 12, I need to find smaller numbers that go into 12. So 1 goes into all whole numbers. 2 goes into 12, so it's a factor. 3 and 4, they go into 12 as well. 5 does not go into 12. It does not go evenly into 12, and so 5 is not a factor of 12. The other factors of 12 are 6 and 12. These are all the numbers that go into 12. In other words, if I divide 12 by any of these numbers, I get a whole number with no remainder. So factors of 16, I need to find numbers less than 16 that go into 16. So again, 1 is always a factor, so 2 goes into 16 as well. 3 does not go into 16. 4 does, so does 8, and of course 16. So they are all the factors of 16. If I divide 16 by any of these numbers, I will get no remainder. All of these numbers divide into 16 evenly. All right, multiples, on the other hand, are bigger numbers. You just count up by that number. So to find the multiples of 12, I just count up by 12. So there'll be 12, 24, 36, 48. Actually, multiples go on forever. So we can't write all of them. I'm just going to write the ... because they go on forever. So multiples of 16. 16 times 1, 16 times 2, 16 times 3, 16 times 4, and so on. So the relationship between factors and multiples is this. If a number is a factor of another number, then that other number is a multiple of the first number. Sounds a bit tricky. So 2 is a factor of 12. That means 12 is a multiple of 2. So 24 is a multiple of 12, so 12 is a factor of 24. So the bigger number is a multiple and the smaller number a factor. Similarly here, 48 is a multiple of 16, so 16 is a factor of 48. So we also looked at finding the highest common factor, which I call HCF, and the lowest common multiple. So the highest common factor of 12 and 16 is the highest number that's a factor of both 12 and 16. So 2 is a common factor of 12 and 16. It's common to both 12 and 16. They both have it in their list, but it's not the highest common factor. The highest common factor is actually 4. 4 is the highest number that is a factor of 12, but also a factor of 16. So the lowest common multiple is a similar idea, but this time we want the lowest one. We want the lowest number in both lists, the lowest number that's a multiple of 12 and also of 16. So we can see that very clearly here. The number's 48. 48 is the lowest number that appears in both lists. So the lowest common multiple, the lowest number that's a multiple of 12, also a multiple of 16, is equal to 48. All right, let's now look at prime numbers. So we saw on the previous slide that some numbers have a lot of factors. So the factors of 12 are 1, 2, 3, 4, 6, and 12. 12 has a lot of factors. So for any number greater than 1, it will always have at least 2 factors, 1 and itself. That was the same for 16. So sometimes numbers will have more factors, sometimes they won't. If they have more factors like 12 does, we call them composites. So 12 is a composite number because it has more than 2 factors. It has factors other than itself and 1. But a number like 13, its only factors are 1 and 13. There are no other numbers that go into 13 besides itself and 1. So we call those numbers prime. So some numbers are prime and some are composite. So just so you're aware, the number 1 is neither prime nor composite. It's not prime because it doesn't have 2 factors. It's only got 1 factor, which is itself. It's not composite because it doesn't have more than 2 factors. So 1 is not prime and not composite. But all numbers greater than 1 will either be prime if they have only 2 factors, or they will be composite if they have more than 2 factors. So in class, we looked at the sieve of Eratosthenes. That was how we found all the prime numbers less than 100. We just have to learn those prime numbers. The only trick I can really think of to help you is that if we're looking at numbers greater than or equal to 10, if they're prime, they have to end in 1, 3, 7, or 9. So the reason for that, if you have an even number greater than 10 that ends in 2, 4, 6, 8, or 0, then it will have a factor of 2. So it must have a factor other than itself and 1. 2 is the only even prime number. So any other even number is definitely composite. Also, numbers greater than or equal to 10, if they end in 5, they can't be prime because they will have a factor of 5. 5 is the only number ending in 5 that is prime. So any other number ending in 5, 15, 25, 755, all of those numbers are composite because they must have a factor of 5. So if a number greater than 10 is to be prime, it must end in either 1, 3, 7, or 9. Some numbers greater than 10 that end in 1, 3, 7, or 9 are prime, some aren't. So for example, 31 is a prime, 43 is a prime, 67 is a prime, 89 is a prime. But that doesn't mean if a number ends in one of these, it definitely is prime. 21 is composite. 33 is composite. 57 is composite. 69 is composite. Unfortunately, this just tells us when a number might be prime. So if it ends in 1, 3, 7, or 9 and greater than 10, it may be prime, but may not be. You just have to learn those primes from the sieve of Eratosthenes. All right, thank you so much for tuning into this video. Keep your head up. You're doing a great job. This has been the luckiest maths teacher in the world. Have a great day.